Hi, today we're looking at Lesson 8.1, Exploring the Logarithmic Function. The goal of today's lesson is to investigate the inverse of the exponential function. The reason for exploring the logarithmic function is to allow us to calculate exponents where in the past we've only been able to discover the exponents by trial and error. Okay, so here's a little bit of a preamble before you get on to the explore part of the lesson. What we're going to be doing is, I'll give you a little background, a little refresher here, and then I'll ask you to do a little explore activity in the textbook. So, graphs of exponential functions. Exponential functions have the form a to the x, where a is greater than 0 and a cannot equal 1. If the base did equal 1, then it would just be a horizontal line, and it wouldn't be very interesting at all. So an exponential function is in this form, of course. They have the following features. Where x equals 0, we'd have x equals 0 here. That would tell us that the y-intercept is 1. The domain is x is an element of all real numbers. And the range, y is an element of all real numbers such that y is greater than 0. And we have an asymptote, which actually ends up being a horizontal asymptote, and the equation of that is y equals 0. So as you can see from this graph, when a is greater than 1, so the base is greater than 1, y increases as x increases. And y equals 0 is the horizontal asymptote. Now, when a is a fraction between 0 and 1, we look at the graph, we see that y decreases as x increases. And y equals 0 is, again, the horizontal asymptote. Okay, so I'm going to ask you to now pause the video, use your textbook, and work through the explore activity, A to I, from the textbook, from pages 448 to 449. The worksheets are the main portion of this exploration, and the textbook is just going to support that. So basically work through the worksheets, which are loosely based on what's found in the textbook. Okay, so go ahead and do those first few sheets, and then we'll do a little summary after we finish that, and then we'll look at a couple examples to kind of get you going. Okay, so pause the video and check back in a few minutes. Okay, so here's the summary of some of the features of exponential and logarithmic functions. So the inverse of an exponential function y equals a to the x, again where a is greater than 0 and a does not equal 0 or does not equal 1, is x equals a to the y, again where a is greater than 0 and a does not equal 1. So for an inverse, we're just interchanging the x and y. The inverse of an exponential function is called the logarithmic function. And this inverse can be written in the form y equals log of x to the base a. So these two things are exactly the same. They mean exactly the same thing. This is the inverse of the exponential function, And this is basically how you would calculate that exponent y, by calculating log of x to the base a. The exponential function f of x equals a to the x, and the inverse, f inverse of x equals log of x to the base a, are reflections of each other in the line y equals x, as you probably would have noted in the worksheets of the Explorer that you just worked through. Now, when we look at log of x to the base a, think of it as the exponent to which the base a must be raised to give x. Okay, so we're actually finding what that exponent is. So the exponent y, notice that it is the exponent, because these two expressions are exactly the same. The exponent y, that means that this log of x to the base a is also the exponent. So by calculating this, you're actually finding the exponent to which the base a is raised to give the result x. Okay, so what I'd like you to do is sketch y equals 2 to the x on a grid, and then draw the line y equals x, and find a few points on both sides of the y-axis, and then interchange x and y and plot points to show you the graph of y equals log of x to the base 2. Then on another Cartesian plane, sketch the graph of y equals 1/3 to the power x. Find a few points on that curve, and then interchange x and y to graph log of x to the base 1/3 to show the inverse graphs. Okay, so do that please on a Cartesian plane. And then if you like to check those graphs, go to desmos.com and graph those, and you can verify what you have done. But graph it by hand first, using your own brain power, please. Okay, so now that we have looked at the summary of features of exponential and logarithmic functions, I'd like you to try your hand at writing the equation of the inverse of each exponential function in exponential form and then in logarithmic form. So f of x equals 3 to the x, that's the same as saying y equals 3 to the x. So then if we're going to write that, the inverse of that, we can just interchange the x and y. So that would be x equals 3 to the y. And then in logarithmic form, we've got y equals the log of x to the base 3. For part B, y equals 1/4 to the x to the power x. So if we were to rewrite this, the inverse of that, we'd get x equals 1/4 to the power y. And in logarithmic form, y equals log of x to the 1/4. And then for part C, we get x equals m to the power y just by interchanging x and y. And in logarithmic form, y equals log of x to the base m. Okay, so now I'd like you to try writing these expressions in logarithmic form. So pause the video please and work on that yourself, and then come back to check. Okay, so logarithms are ways of calculating exponents. So we know the exponent here is -4, and that is equal to the log of the result to the base. Part B, the exponent is equal to the log of the result to the base. in this case 2. And again here, the exponent is log of the result to the base. And in this case, the logarithm, the standard logarithm, is always to the base 10, and that's understood. So that 10 does not have to be written. Just like with square roots, the 2 in the root does not have to be written because it's understood. Okay. Now we move along to expressing these in exponential form. So again, just rewriting them. Okay, so we've got the result equals the base to the exponent. The result equals the base to the exponent. And again, the base to the power 4. And now moving along to when we're trying to evaluate things, I generally like to set this equal to x to get an equation and then write it into exponential form. So the result is the base to the exponent, and then I'll see if I can get a common base. So I change that into exponential form with a common base. So if I've got two powers that are equal and the bases are equal, then that means that the exponents have to be equal. Again, do the same thing here. So 25 equals 5 to the power x. 25 can be written as 5 squared. So because the two sides are equal and the two bases are the same, then that means that automatically the exponents have to be equal. And for this one, 64 equals 4 to the power x, because x is the exponent. I can rewrite 64 as 4 cubed. Okay, we get the common base. So the two sides are equal, the two bases are the same, therefore the exponents have to be equal. Okay, so please work on the first few questions at home, and we can work on the rest of the questions at home, at school, and the worksheets. So please, depending on how much time you have, get as much done as you can, because there's a fair amount of work on the worksheets. Okay, so thank you for your attention, and we'll see you in class.